Okay, everyone, welcome to this week's PQ Interop call. The goal of this call series is to serve as a touch point for researchers and client devs during the iterative process of developing, deploying, testing, and improving a series of dev nets focused on aggregating post-quantum signatures. And this breakout room supports the longer term goal of lean consensus vision. Let's dive in. I've got the agenda in the chat. I think that there was some discussion around perfect consensus. Roberto, thank you for staying up to the wee hours of Australia's evening. Is there anything that you wanted to start us off with?
Yeah, I think mainly just probably repeating what I wrote in the message on Telegram. So my idea was that because of the scenario where we essentially have synchronized clock, we can essentially manufacture consensus by having each node, each validator at the beginning of a slot to sign a message, depending only on the number of this slot. And in this way, essentially, all validators always agree on what to sign. And in this way, we don't run the risk that, for example, if we use some form of for choice, perhaps some validators are a bit behind and they vote for a different block than other validators, and we cannot aggregate signatures. So this was overall the idea behind what I wrote on Telegram. And theoretically, the reason why we can do this is that essentially we have a trivial consensus algorithm, meaning that essentially there is only one value possible that it can be decided, which is essentially the number of the slot. That's why we can do this.
And Roberto Gajinder threw his hand up pretty quickly. Maybe we'll maybe Gajinder, I don't know if you had an initial question on setting context for this.
Yeah. So Roberto, as you mentioned that, yeah, so the consensus has to be pretty light and simple, and clock is synchronized anyway. I mean, that is the basic assumption behind the beacon protocol as well, that the clock is synchronized. And so that is what we are aiming for. What we discussed with Dream, and we believe that chaining is sort of important. And once you have chaining, so some sort of finalization is also important, because otherwise the clients will become stable over a long period of time, and it will become too forky. So with that regard, we basically decided that we will go with just chaining, basically, having a parent-child relationship and validation of that in the consensus. And for fork choice, basically, we wanted to go with 3SF mini because it looked simple enough, and Zeem was able to implement it pretty quickly, and I believe Reem is also able to do that. So with regard to that, I believe our choice of chaining and 3SF consensus is pretty minimal and simple. With that regard, to kickstart this DevNet, where we don't think that a lot of time will be spent while running the consensus, and it should be pretty trivial, not in terms of implementation, but in terms of client running, proposing and basically running running the state transition function. It should be pretty simple and trivial for the client. Also, it is simple enough for teams to implement. I mean, Zeem and Reem both have it. So in that sense, we don't see any challenge over it. And for block production, definitely we will do a round robin based upon the slot. So that has already been discussed. So in that sense, we totally are on board with your proposition of keeping the consensus simple. And we believe that chaining plus 3SF plus round robin block proposal is keeping it simple.
Thank you. So my proposal is essentially to eliminate consensus. So my proposal is consensus is so simple that there is no message sent to arrive to any consensus.
But if there is no consensus, so that way, I mean, we won't be able to calculate which one is the canonical chain. For example, why is that important? Because it is important because, for example, if their aggregation is late or if voting is late, then, for example, canonical chain would be different. So there should be forking, right? So if you
Sorry
want
to interrupt you, but there is no chain in my proposal. There is just no chain at all. Sorry to interrupt you because
I understand, but what I'm saying is that tracking chain is important to figure out how efficient the scheme is, whether all clients are able to vote in time. And so basically taking all these delays and coming into an aggregate number of attestation effectiveness, because head vote accuracy is the most important metric that we need to track. And with that regard, I think chain is pretty important to have.
Isn't the objective to measure the performance of the signature aggregation? That is the objective, right? We want to measure some metrics like how long it takes us to aggregate a given number of signatures, or plot in some graph of, right?
That we don't actually need a DevNet. The objective of DevNet is to run post-quantum signature scheme in entirety, end to end, and see, what are the challenges and what are the metrics that are out there, which include time for signature aggregation, which all the clients will be doing that. But just for the purpose of benchmarking signature aggregation, we basically don't need a DevNet. So Kamil basically is also running some sort of simulations, right? So we will have some benchmarking results even from simulation itself. So with that regard, I think there are other paths to do benchmarking and to figure out whether signature aggregation is efficient enough or not. Or if, for example, there is some particular signature size, what is the expected delay that we can expect on a simulated network? And through network simulator and all these tools, I think we will get a good idea about that. But post that, we basically want an end-to-end measurement of what this post-quantum signature DevNet look like, including and now, this is not just, for example, about signing and aggregating. It's also about, for example, Genesis generator or Genesis generation and key store generation, because now the validators will start from a seed and they will need to generate private keys and sort of come to a public key. And so basically overall process, right? So it is sort of and in entirety, this particular experiment that we and Reem sort of thought about, and we basically started on it. So aggregation is, I would say, a part of it, although very important part of it. But what we are trying to go over here is basically, see how it really works out in action.
So which are the parts in addition to, in addition to aggregation, what are we trying to measure? Sorry, I missed that.
Yeah, so we would basically, we basically need to figure out what is the best form of Genesis generation. But I mean, although it is generally for testnets and for mainnet, it would be hard forked into. But the point of that is how, for example, a post quantum key would be generated and registered, right? So that could be a later stage. Registration could be a later stage goal of see how it works out in the real. But at least for example, if you want to start up a validator and you have a key store, how much, for example, lead time you need to generate your private key and to basically start up the validator. I mean, all these things are logistical things, but they are quite important. Other thing would be measuring signature time, measuring the bandwidth in the real scenario, and as well as what are the delays that are happening, right? So measuring the latency and measuring the hops, whether we can improve gossip sub or what are the delays, what are the hops that we are getting with the current gossip sub. Is there another grid? For example, there is a square grid proposal that is out there. Is there another grid that we can basically have so that we can propagate faster? Then aggregation is definitely one of the points, and the verification of signature is definitely one of the points in that entire scheme. So the consensus of chaining and 3SF finalization, that is I think very small bit, and we don't see it as a computational or resource hurdle at all.
So my concern is that it's not so much about the complexity, is that because it's possible that if there are delays on the network, different nodes on the network have a different view of the tree, and therefore they send votes that are different, that cannot be aggregated. And then if this happens, then you don't know if the aggregation doesn't, if the aggregation, if you don't get enough aggregation because the aggregation process has some problems, or because the consensus protocol has some problems. So my main concern in all of this is that that we have two moving parts. One is consensus, one is aggregation. And if aggregation doesn't happen, we don't know if it's because of the aggregation, a problem with the aggregation scheme, or with the infrastructure of aggregation, or the infrastructure of consensus.
I understand where you're coming from, but we believe that consensus is pretty simple and simple to understand and implement with regard to just chaining and 3SF. So we don't see much complication arising from that, to be honest.
So I'm not saying at all that is complex. That's not what I'm saying. I'm saying you implement the consensus and it's simple, but consensus does not guarantee you that nodes will vote for the same block. Because if there is bad network condition, you can end up with nodes having different views of the chain, and therefore they don't send messages that can be aggregated. You see what
Right.
I'm not speaking at all about simplicity. It's about the
right,
problem that you can have.
I understand, but having a consensus is not complicating that problem, right? So having a consensus will basically help us figure out whether the problem is because the nodes have a bad view of the network, right? So consensus will tell us whether there are some nodes who are, for example, on a fork, rather than it would become more complicated and sort of more messy if we don't have a consensus and we just try to generate matrices based upon just signatures and signature aggregations, right? So I believe that having consensus, basically having a definition of canonical chain, right? Why we need consensus? Because we need a canonical chain to figure out what is the head accuracy. And why are we using 3SF? Again, for the stability of the network, it's not really required. We can also junk it if we see complications in that. But the basic thing is that this is a very simplified consensus that we believe will actually help us differentiate between whether whether the performance issues or the degradation in matrices are arising out of consensus issues, or they are arising out of some other libraries that are out there, or performance of the aggregation or verification. So in that regard, we believe that our choice of this particular consensus will actually help us. But if it won't, we can always junk it and come back to it. I mean, it doesn't stop us to do what you are proposing, but I believe that it would be easier if we have a well-defined canonical chain that we can track and we can basically define our metrics on.
Roberto, I guess in the spirit of doing iterative dev nets, are you suggesting that we should? It sounds like you have concerns about coupling the signature aggregation with consensus. Are you just suggesting that we should increment our way towards combining those two, like start with just consensus and then layer on signature aggregation?
No, I'm suggesting we should. So in a way, you can say that what I propose on Telegram is a consensus. Essentially, another way to look at it, we can have a predefined chain. We can have a chain with which we already agree on, which is pre-minted. We have a block for each slot, and each slot you propose exactly the block that everybody knows, or everybody votes for the block that it's already agreed up front. Like imagine your Genesis, and I don't know, we run this DevNet for 10 days or whatever. We already have a predetermined chain. Every node knows exactly the chain that they will vote for. So every node already agrees. That's the thing. Like there is consensus. It's just implicit, and because of this, well, one I think it's simple, but that's not the thing is you are never going to run out in a scenario where nodes disagree. But if you implement 3SF or whatever, it is possible that nodes disagree. And now if nodes disagree, they cannot aggregate, you can't aggregate the signatures.
Gotcha.
In that
before
regard,
go-
I really disagree that in absence of consensus, it would be difficult to establish whether the nodes agreed or not. So that is my response to that. I think we should also hear from Ream team what their thinking is. And as O already pointed out, we will basically, first make sure that we are able to interop just with our simplified consensus and then bring in signatures to it so that we can deal with complexity properly.
Camille.
Yeah. Sorry, maybe a stupid question, but in 3SF Mini, are we going to have like multiple aggregations happening at the same time? Because like some nodes are voting for current round and others for the previous round. Is that correct?
So basically the aggregators will basically aggregate based upon the head data, right? So this is how aggregation generally happens in beacon consensus as well, that the votes are aggregated based upon the target, based upon the data that you are aggregating on. So similarly,
but some nodes are voting for the source, some nodes are voting for the target. Is this happening at the same time or?
So in Mini 3SF, so basically the votes are generally for the head, source, and target as well. So I think for all threes need to be the same for them to be aggregated.
Yeah, just my concern is that if it's happening at the same time,
source,
then
right?
it's probably, is that realistic how it's going to be eventually? Or we will have like different sets of validators voting for different rounds? Because if in reality, like we have multiple,
it will likely be the latter. So in high latency situations, for example, like different validators will have different views on what these source target head triples are, and it's actually important for incentivization that even if, for example, your view of the head is incorrect, but you still have the source and target correct, that you still get a reward for testing. So yes, the short answer is we will be aggregating over different messages.
Okay.
Yeah, so I just want to point out again what I typed that so we are planning to do the mini consensus first and then mini consensus plus the PQ6. So hopefully that should de-risk like figuring like being able to troubleshoot issues that are blurred between the two. So that's the first thing. The second thing is I actually have a question on if we are going to go ahead with like Roberto's proposal is if we don't have chaining, so basically only have the slot number but without the parent, then aren't we going to be only aggregating um the latest view, but we won't be able to figure out whether it's the same chain. Like some validators might be missing some heads, some are not. So I think that might actually make it harder to get a shared view. And the third point, the last point I want to make is I think we can actually measure separately between the signature validation, right? That the signatures is correct. We can actually measure that separate from the actual consensus. So if we are concerned with just measuring the PQ signatures performance, then I think we are able to do that even though we don't have consensus on what the content of the attestation is.
Roberto.
Yeah, thank you. So, if I understand correctly, you're asking whether what I'm proposing could be that there are, I don't know, the validators fall behind or they don't agree, don't see the same thing, right? But the probability that's just impossible. Like we can have a chain. We can like imagine we pre-compute a chain. We can have a function that for each slot gives us a block with a parent, the block from the slot before, and every validator knows exactly what to vote for a given slot. So this is it's just that it's predetermined. And we can do this because in what we are building, we don't care about having actual transactions. So like we can predetermine the entire chain and each validator knows exactly what to vote for at each slot. Meaning they'll agree by default, like it's impossible they will disagree. So I have a question so this is my question is, if we can have a perfect consensus where at every slot you are guaranteed, despite, even if there is complete network asynchrony, very high delays, that all validators will vote exactly for the same chain, and you have another consensus that doesn't guarantee you this property, why would you not choose the first one?
So in CAN, we actually did have this as a proposal. And so that was for EFCC. And, it is definitely possible to have a DevNet with this perfect consensus, which is super simple, and then move on quickly after. My take is that I don't have a strong opinion on what we do, but if we were to have this perfect consensus, then we probably don't need it for very long, and we can move over to something more complicated pretty swiftly. And it seems like the teams that are building this, like Reem and Zeem, basically have a preference to just go directly with something a little bit more sophisticated. And you're right that if you really want to isolate the testing of the signature aggregation, then it's possibly better to go with this perfect consensus. But I think, as Gajin tried to explain, is that there's all sorts of other things that we need to test related to consensus and fork choice rules and whatnot. So yeah, ultimately it has been considered a couple months ago, and I don't think it's a super important kind of decision at this point.
If I may, I want to respond to Roberto a bit. So on predetermining the chain, I would actually kind of question whether we'll actually need interop for that. It sounds like something that each of the client would be able to run on their own and give us like the performance measurements there. But however, I think it might be a good precondition before going into actually running the Interop DevNet, that each of the client is able to sign and attest to their own like predetermined chain, or even like a predetermined chain that's shared between the two clients but run separately before actually committing to or like starting to like interrupt that.
I mean, I think it could still be a value. I mean, for Interop, even if you go to this perfect consensus, as you might want to see how the signature aggregation implemented by different teams, they combine together. Potentially, there could be a reason there. Still, to check how different implementation of the signature aggregation algorithms work together.
Well, I dropped a note in the chat reminding folks that we sort of self-assigned this DevNet 0 to be due August 31st. That's 2 weeks from today, approximately. Is there anything that's been brought up in this discussion that sort of undermines that set of objectives? It looks like in the chat, O is saying signature chaining is sort of infers, I think we met parent chaining. Okay. And then there's significant work we need on tooling, Genesis generator, kurtosis. So this looks aggressive. Yeah, maybe on that note, let's put a pin in this topic for right now. And Gajender and Barnabas, I believe you guys had a conversation about some of this tooling yesterday. If you could maybe give us an update, let us know where we stand with that as a dependency.
Yeah, me and Barnabas had a discussion over this, as well as some discussions with Pari async. And yeah, so I will let Barnabas take the lead on this.
Yeah. Hi, guys. I'm Barnabas from the Interop team. So I will give a quick update on what we need every client to basically get up to speed. You need Docker images for every single client that want to participate in this DevNet 0. We can add support for our automatic ETH client Docker image builder, and we're going to be able to build ETH images for any of your clients. We're going to need a fork of Ethereum Genesis generator. This fork will be able to create the Genesis files for whatever file format you're proposing to have. The underlying library here that also needs to be updated is the ETH Genesis. I'm including links for all of these. So the ETH Genesis is basically the underlying library which creates the SSZ format for the CL client. This SSZ structure is probably going to be different for this DevNet 0. So this fork has to be created, and in order to support the different validator key structure, we're going to need to have a different fork of the E2val tools. So E2val tools is the one that generates the current private and public keys, the BLS keys for all the different CL validator clients. Ideally, we need to figure out how long does it take to create this post-quantum signature, whether we want to generate all the validator keys in advance and shove it in a S3 bucket and pull it on demand, or we want to generate them on demand with kurtosis. We can come back to this later. And then lastly, we probably want to maintain a fork of the Ethereum package, which will give us support to test all these clients locally on your local machine. But yeah, if you want to have visibility, we probably also need to have a fork of Dora. This is a Go project, lightweight beacon chain explorer. Can probably have a fork of this, and yeah, the whole validator structure is going to be different post quantum, so it might be quite some work to get Dora up and running. We might just have to use the Prometheus metrics for initial DevNet 0 and maybe have Dora support for a later DevNet, but all the other ones would be a prerequisite in order to get DevNet 0 up. Regarding the open questions, mainly the validator key generation, whether we want to do this in advance or on the fly. Would anyone have experience in generating these validator keys with this new library? How long does it take to generate one, and how big the key is, and how long would it take to generate 1,000 locally on the machine, and how big they are?
Any takers?
I mean, I don't know for sure, but I think the longer it takes, well, it all depends on how long we're going to run the Curtis's chain, basically. If it's just few minutes, we don't need to spend a lot of time generating the keys, right? Then it's
10
pretty
days.
done on the go.
So
Or
the size of the
produced.
keys is about 50 bytes, if I'm not wrong. So it's like one Merkle root plus some 5 field elements maybe. So it's like, yeah, 50 bytes.
Okay, so it's a
And
tiny file, but how long does it take to generate the key? If you want to have a runtime of
Hours,
10
order
days.
of hours to generate one key.
4 to 5 hours.
In the order of hours, I'm not sure if it's
Or
4
order
or
of
5.
hours. Okay, okay.
But
So we could
also, I mean, you are flexible. If you generate the keys, you don't have to go to the maximum lifetime, which is 2 to the 32. If you do that, then it will take you not hours, but days. If we all agree that we do 2 to the 18, then I suspect you can do it in a few minutes. But I would have to rerun the benchmarks again.
And if you want to have like a 1 hour runtime, because for Kurtosis it doesn't really make sense to run more than an hour, then it could be done
1
in
hour to generate one key or to?
no 1 hour runtime, not 10 days, but even less slots.
For a single key.
Yeah.
Yeah, I can check that, but
Do we
yeah,
have a tool
I
for
mean,
this, like the key generation tool? Do we have like a Docker container for it, so we can like start playing around with it?
no, I mean there's a Rust library. That's all we have.
Rust
Right?
library, okay.
But I can check the key generation time.
Yeah, it would
Yeah,
be
maybe
nice
to
to have
clarify.
some metrics.
Yeah, Benedict, maybe you know out of your head, like we just need, if we need to run a chain just for an hour, so it's just every 4 seconds, it means 900 slots. If we just need the key for 900 slots, like how long it takes to generate such key?
But that will be extremely fast. If you just want 900 slots, that's not even 2 to
Yeah,
the
maybe
10.
then it's
So
good
yeah.
enough.
I mean,
Right,
if you, I have
so-
some old numbers, and numbers should be better than that. So for that, lifetime 2 to the 18, so that's already much more than 900 slots. That should be 270 seconds, maybe. Yeah, that's a few minutes. So
can it be parallelized? Can we
no,
generate multiple keys?
it is already parallelized.
No, but you're talking about one key. What if I want
Yeah.
to create 1 million keys? To
I
like
mean, of course, you
mainnet?
can do that independently, but already generating one key is already internally parallelized.
Okay, okay, got it. So in theory, it should take the same amount of time if you generate 10 keys, if you have enough
Yeah.
cores.
Oh, sorry, that number that I gave you was for different hash functions. So let me revisit that. yeah, still 330 seconds for a single key, but that's old numbers. So right now it should be even faster for lifetime 2 to the 18 because we improved the code since then. Yeah, so I can give you more accurate numbers after the meeting. You can just ping me.
Yeah. So ideally what we want is we want to have a new validator key generator where we can set what kind of lifetime we expect Kurtos's DevNet to have, and then we can probably generate them on demand. And if it's really just takes sub 1 second to generate it for like 900 slots, it makes sense to just have a new key generated for each run. And then for larger DevNets, like DevNet 0, when we're talking about longer lifetime, it probably gonna make sense to have a beefy machine. We're gonna be pre-generating all the keys. We're gonna shove it into an S3 bucket, and we're gonna be calling. We're gonna be basically pulling the validator keys on demand when we spin up DevNet 0, and we don't then have to wait multiple hours to generate these longer lifetime keys.
And Barnabas, just to be clear, this is not work that Eve PandaOps has the bandwidth to do. We're looking to assign that to this group.
Yes. So currently our primary focus is on Fusaka work. We can do basically no work before we can ship Fusaka, and we're gonna have best effort after Fusaka. But
Sure,
yeah,
makes sense.
feel free to fork any of our repos and ask for input, and then we're gonna try to get back to you.
Camille, in the chat, the Telegram chat just prior to the call, you'd mentioned maybe joining the party with building a client implementation. Just curious, like hearing this, I don't know, like I'm just kind of like thinking on my feet, but would you be in a position to help set up some of this like overarching infrastructure in lieu of doing that, and then, or would we prefer to have a third client implementation and kind of disperse this this work amongst everyone?
Yeah, you mean this kind of infrastructure? You mean Kurtosis and all of the stuff, or?
Yeah, Kurtosis, Dora, the signature generation, or all of the things that we're going to need basically to be able to bootstrap the first DevNet.
I don't know. I never touched the Kurtosis, so I need to check it
Okay.
out.
Sure,
before
sure.
answering.
By the way, Kurtosis would be like step 5, and that is the part where I can actually help quite a bit on. All the other, like the underlying libraries and all the prerequisites would be the main heavy lifting here, in my opinion.
To Genesis generator, I think I and the game has some experience in dealing with that, and maybe we can sort of take a look into it and come back whether we can support it. But I think coming back to the logistics of key generation, what I suggest is that we have that as a separate step, which is not really integrated, because then, for example, somebody in the chat noted that we can maybe try to use the same generated keys over and over again for local testing. And I think that is a very good idea, because we wouldn't want to wait minutes for a local DevNet to start up. It would get frustrating. So in that sense, I think it would make sense to sort of separate it out as a 2-part process, where the key generation happens prior to the Genesis generation, and the Genesis generator can just use the generated keys and the generated keys config to generate the Genesis. And those generated keys can also be easily distributed among the validators, or validators can just pick and choose. And this would also tie very well into the long 10-day long running DevNet, where we would just generate the keys and pull them from the buckets. So I think
just to chime in here, I just reran the benchmarks for the most up-to-date code, and for generating 2 to the 10 keys, because you said 900 slots, it took like 2 seconds to generate 1 key.
Right, but we would probably want to run around 120 to 250 keys at least even
Then you
for a
just
local
take
test.
that number and multiply it by that.
Right, but
Like-
that's the question, like how parallelizable is it to generate 200? Like how long does it take to generate 200 keys parallel?
I mean, the key generation is internally parallelized, so I'm not sure how much you would gain from parallelizing over the different keys.
Right, that's the main question here, I think, because if it's, 2 minutes, that's too much. If it's 20 seconds, that's too much. If it's 2 seconds, then that's something we can deal with. I think anything over 2 to 5 seconds is too much.
But I
For
mean,
local.
if we at any point go to realistic lifetimes, then it will for sure be much more than that. Like with these
but-
schemes, for realistic times, you expect like hours of key generation.
Right, and for that, we can always use the pre-generated keys.
I see.
I'm just saying that fetching on a kurtosis network, fetching a file from remote might take longer than generating it locally. Then at that point, we might as well generate it locally. And that is gonna allow us to also work offline. Like right now, one of our main selling point is that we can basically run a whole kurtosis enclave offline. We don't rely on any external dependency. We don't rely on the internet. So ideally, we want to keep it that way, especially if it's fast enough.
I see.
And this is why I think we need an independent tool that does the key generation, where we basically take 2 or 3 inputs. One is going to be how many keys we want. The second one is going to be what kind of lifetime we expect. And the third one could be like, where do we want to store the key files? And that's it.
Okay, I guess that can be created just from the library. I mean, the keygen function already has this.
Yeah, exactly.
Parameters.
Yeah. So just have a library for it, add a Docker file, and add that tool to our image builder, and then you're gonna have a itpendops post-quantum key generation tool, and then from that point on, we can integrate that into all the other testing stack as well.
One thing worth noting is that if you pre-generate the keys, you can have the public key be pre-generated, and all of the private stuff can be subsumed to just your seed, and then you can basically regenerate it in real time. So
I'm not
it's
sure
not
that's
like
true, Justin. I mean, you can generate the actual secret stuff, but the stuff that you need to sign fast, you should not, like, you cannot. Generating
Right.
that would take as long as generating the key in the first place. So I would not throw that away. I would store that.
Well, you can store basically maybe a layer that's halfway through, and then that's like square root the size or something like that.
Yeah, my other
Right,
question
but
would be,
I
how
guess
big is
that
the key?
in practice, I would just store the entire key.
How big is this key for one validator? The whole thing.
That again depends on your lifetime, right?
Oh, the lifetime, yeah. So like 2 to the 18?
Yeah, times something.
Okay.
I mean, it's an entire Merkle tree with 2 to the 18 leaves.
So it could be actually gigabytes of data.
Yeah, for sure.
Yeah.
I mean, you can throw it away, but then signing is incredibly slow. So, and I guess we want signing to be fast.
Yeah, so this is where the square root idea comes in. You only store, let's say, 100 kilobytes, and that's enough data, and you can still sign every block by computing a little bit locally.
Is it such a problem if the secret key is that big? Why do we care? I mean, validators have space anyway, right?
No, but like if you run up for example, a local network, and you need to fetch, each time you run something, you need to fetch 500 gigabytes of data, then that's going to be a while. Like, sure, we can do it one-off, but I'm thinking here local test. On your home network, for example, you want to run 500 validators, you're going to need to fetch 500 gigabytes. Then that's significant.
Okay, great. I will do my best at synthesizing this conversation into like a preliminary like DevNet readiness plan of things that need to be accomplished and try to socialize that so that we can get people to volunteer for who's going to take what and try to assign some time to this and see what sort of impact this is going to have on the overall schedule. We've got a lot of people are gathering in October for a small interop, and we've got about 7 weeks from now until then. So I still think goal is to like get this infrastructure in place and have already done a single DevNet prior to that gathering if possible. So I will try to get this pulled together here in the immediate future. And then we've got 12 minutes left on the call. I will drop the links that you had on the comment, the 2 PRs that you wanted to talk about, if there's anything here that you want to call attention to.
Oh yeah, maybe quick update from our discussion last Interop.
Yeah.
I think Guillaume mentioned that Zeem was using Union for the optional fields on the SSE, but I think I looked into like Zeem implementation and it looks like you're also using zero hashes instead of the optionals. So would love confirmation there. And if you're using zero hashes, I think that's great because Ream is doing that too, and it's a lot less complex to implement.
Yeah, we are also using zero hashes on that. Basically, we had a discussion on this and sort of got clarity on what exactly you were asking. But with regard to your PR for containers, can we sort of have that .md file like we have in the Mon consensus specs and basically start the container definition from there. Yes, right now I think you are basically we have some comments over there, but we can do on the PR once we have .md container definition file, because commenting just on the Python code doesn't seem appropriate for a discussion.
Yeah, definitely. I can do the MD file. But maybe a question to Felipe. Do you have any thoughts on that? Because I think you wanted the specs to be in Python and follows your framework, right? The specs framework.
Yeah, I don't have a whole lot of context on how we want to organize this. I think we need to make a decision kind of as a group. I kind of came in just to make sure we're using all the same tooling across the specs, but I'm sort of new to how we want to organize it as well. So something we need to discuss together, I think.
Okay, cool. Makes sense. I think like in that case, I'll create the markdown files, and for like, Ream and Zeem, we can agree on the markdown files. And once we agree on the specs, I'm happy to try out put it into like Felipe's frameworks. But yeah, I'll sort out the markdown file.
Yeah, I did make a comment this morning on there, and I reached out to you, Tomas, just to see if you had any opinion there. But if we could move them out of where the Python is and maybe into docs for now, and we can think about how to organize it beyond that as well.
Great.
So I think,
Yeah. I was just going to throw it back to you if you wanted to discuss those PRs.
No, so I'll get back to the PRs, turn the code into Markdown files, and then I'll let everyone know in the Interop group.
Great. In the chat, let us drop the note. As far as I know, we discussed minimum 1,000 validator devnets in CAN. Given the key generation constraints, should we consider lowering that number to low hundreds? Gajender chimed in. I guess we could start with 100, at least initially.
Does it matter? Maybe we could have 10. I don't think the number matters as much as like just getting the basic steps out of the way, figure it out. Changing 1 or 10 or 100 doesn't really matter.
Yeah, I think once we have all the tooling in place, we can easily sort of experiment with this and scale it.
Sounds good. In the remaining time, did anyone else have anything else that they would like to discuss? Okay, great. I will, like I said, work to synthesize notes and first draft of a readiness plan. I'll probably run that by you, Barnabas, and maybe Gajender and O first, and then just open it as a PR so that everyone can comment on it and get a sense of who's gonna take what. All right. Thank you all. Talk to you soon.
Thanks, Will. You will.
Thanks, everyone.
See you guys. Bye bye.